I may have forgotten to start recording. I'm continuing with Go today. I finished this. I learned about the walrus operator. Don't need to say what kind of variable it is. Type inference, thank you. Um, why Go? Okay, here I fixed a little math bug. This was a plus instead of a times. Comments, sure, basic, simple compilation process. This little bracket was missing. And faster. Go generally runs faster than other interpreted languages then interpreted and compiles faster than other compiled languages, but it is not necessarily faster than other compiled languages. Okay, let's continue. I did also solve the classes practice. I had a very nice discussion with Boots. Well, basically from the remove book function onwards, I was just not getting this if function or this if loop right, or the for loop basically, nested if. It's better now and it's working as needed. We can run it, it'll pass. Unsigned integer, okay. Integer. Integer or integer? I think integer. Oh, unsigned means if it's a plus or a minus in front of the integer. Is this unsigned integer pointer? I guess we'll find out. Okay, it just cuts off. Doesn't bring it to the closest integer value, it cuts it off. Need to get more used to the walrus operator again. So here's a bit of background. My first coding language was Delphi. Walrus operator was all over that motherfucker. Um, yeah, I've been out of the game a long time. I really hated coding when I was young. I just didn't enjoy it. Now I don't have a choice anymore. Now I want to build a future for myself. The big boy. I'll read that afterwards. Nice. All right. Should have gone with the 3000. Should have, but oh well. Go is statically typed. Variable types are known before the code runs. Is that what it means? More than enough. What's going on here? Oh, no, that's the. Never mind. Okay, let's try this again. Stop this for a second so I can focus.
Languages have better developer experience than compiled languages. This is some of the stuff that I'm hearing online. Let's actually break it down and talk about the difference between a compiled language and an interpreted language. When we write code, we write it in a human readable format, right? Typically in a file, in the case of Go, a .go file, right? Maybe main.go. And this file is going to contain human readable text, right? Go code that we as developers work on. The thing is, your computer's hardware doesn't know what any of that human readable text means. Your computer's CPU only understands binary, right? Which is ones and zeros, right? Which at the end of the day is just numbers, right? But it's just numbers and simple operations, things like add and subtract. So we need some process that we can use to convert human readable code to machine code that can be executed by the computer's hardware. And that's all that compilation is. Compilation is just the process of taking some human readable code, right? Go code in our instance, and converting it to binary or machine code that our computer can actually understand. So, what does this process actually look like? Well, normally you'd start by writing your Go program. So say main.go. And you'd run it through the Go compiler. On your command line, you'd type go build. And that would produce a new file, which is the executable program. Let's say we were doing a hello world program. It might be hello world.exe, right? An executable program on your computer. And then you could run that executable directly on your operating system without ever having to use the Go toolchain again. So the great thing is you can take this hello world.exe program and give it to someone else and they can run it on their computer without ever having to install the Go toolchain or even know that you used Go to build the program in the first place. This is different than languages like Python, where if you want to run someone's Python code, you have to use the Python interpreter every single time and you run the source code directly on your machine. It's also worth pointing out that part of the reason that compiling is so much faster at runtime is that we do all of this compiling work up front. So when we go to run the executable, we don't have to do any conversions from human readable text to binary machine code. That's different than how interpreted languages work. With an interpreted language, as we run the program, the interpreter is reading the human code and kind of at runtime converting it to machine code that the CPU can operate on. Not to beat a dead horse, but I want to talk a little bit more about execution speed. So, we talked about how Go is generally faster than the interpreted languages, right? Python, JavaScript, Ruby, PHP, and so on. It gets a little interesting when we compare Go to kind of the natively compiled languages or the languages that compile directly to kind of machine code that runs on your CPU versus the compiled languages that run on top of a virtual machine. Right. So the two big ones that run on a virtual machine are Java and C Sharp, while some of the compiled or natively compiled languages that you'll be familiar with might be Rust, C, C++. Even though Go is a natively compiled language, a language that compiles directly to machine code like Rust, C, and C++, its execution speed is actually more similar to Java and C Sharp when it comes to its runtime speed, how many computations it can do kind of per second. And we'll talk more about this later, but the primary reason for that is the Go runtime. There's basically a chunk of code that's included in every Go program that manages memory, and that tends to slow down the execution speed a little bit. That said, it is worth pointing out that a Go program tends to use much less memory than Java and C# because there isn't a need for an entire virtual machine. Go, Java, and Rust all have very different approaches to how the can have a huge impact on program performance. And there are two things that we mostly care about here. One is speed, how fast your program can do computations, which is roughly measured in the number of CPU cycles required to get the job done. The other is memory usage, that is, how much memory, usually RAM, the program needs to store its data, or your program's variables, while it does those computations. In languages like C, Rust, or Zig, memory management is effectively manual. You as the
So you tell the compiler how much memory to allocate for your variable. Okay.
developer explicitly allocate memory by writing code that says, hey, this chunk of memory will store this data, And later, your code signals that it's done using that memory so that it can be freed up and used by other programs. In Java, things are different. Java's garbage collected, which means that memory management is automated. In Java, it's handled by the Java Virtual Machine, or JVM. When you run a Java program, you're actually starting up a virtual machine that executes your Java program's compiled bytecode. The JVM is responsible for allocating and freeing memory on the fly as it's needed. But this automation does introduce some overhead, and Java programs often use more memory than equivalent programs or similar programs written in languages like C. Now, Go falls into an interesting middle ground. Like Java, Go's garbage collected, so memory management is automated. But unlike Java, Go does not use a virtual machine. When you compile Go code, you get a single natively compiled binary just like you would with Rust or C. The difference is that this Go binary includes a runtime. It has an extra bundle of code that is compiled into every single Go executable. This runtime is what handles the garbage collection, other features like Go routine scheduling. One important aspect of Go's memory management is that it's often able to allocate more data on the stack than a language like Java does. And stack allocations, when possible, are more performant than heap allocations. So as a very generic rule of thumb, Go programs tend to use less memory than Java or C# programs, but because Go is still garbage collected, it does tend to use more memory than programs written in C or Rust.
And okay. Time difficulty. Really? Free XP for me. Last one isn't as hard as freaking class practice. I might finish this video on that. My 25 here it would just say int 64 maybe, just int. Because that would be the default, I assume. That's solved. Okay. See. Using the format pattern. Same. That looks right. Awesome. Right. It's a good little session on Go. Chapter 1 complete. A lot more to go. I'll be a disciple next. How nice. Grandmaster coming close. My first Grandmaster achievement. That'll be nice. Well, okay. See you all in the next one.